Hi students, in this lecture I am going to discuss angular momentum. Let us see. Consider a point mass, or we can say particle, which is moving with a velocity v. So this is now momentum vector of the particle, and for this particle, position vector is r bar. That means we are taking our origin somewhere here. With respect to that, its position vector is r bar. Then angular momentum of the particle about origin is defined as r bar cross p bar. Okay, so this is equal to m into v into r sine theta into n cap, where n cap is unit vector which gives direction of r bar cross p bar, and we know how to find direction of n cap, right? Using right hand thumb rule. That means keeping the right hand on first vector, that is r bar, curling fingers towards second vector. If you see in this diagram, if you put your right hand on r bar vector and curl fingers towards p bar, then thumb will be into the board. That means direction of L bar is into the board. Okay. And you can see here one more thing, that is r sine theta, which is known as perpendicular distance. See how to get it? Just imagine one line passing through the point. Imagine line passing through the point about which we are calculating angular momentum. Then the distance between that line and this momentum vector. So this is now r sine theta. Okay. And you can see angle theta. That is the angle between the vectors r bar and p bar. Okay. So simple writing m into v into r sine theta into n cap. So whenever we want to calculate angular momentum, so first we try to write r bar and p bar. Then taking directly r bar cross p bar. If it is not possible to write r bar and p bar, in that case, we multiply modulus of momentum with perpendicular distance, that is r sine theta. Okay, let us take two problems to get more clarity. See the first question. See the question given. A mass m is moving with a constant velocity along a line parallel to the x-axis away from the origin. Its angular momentum with respect to the origin is. So asked for 1 mark in 1997. Given like it is 0, remains a constant, goes on increasing, goes on decreasing. Let us see how to use now this concept. So first condition is it is moving along x-axis. Suppose this is x-axis and this is y-axis. Condition given that it is moving with a constant velocity parallel to x-axis away from origin. Let us say it is now moving like this. Constant velocity means it follows now straight line path, right? Suppose like this. It is moving now along this line. We can say moving along this line. Now the particle can be anywhere on that line. Now, the particle can be anywhere on that line. Suppose at one instant somewhere here. Okay. So now we have to get angular momentum about origin. Then see what we are doing here. If you take at that instant, this will be the position vector of the particle, and this is now momentum vector. This is r bar and this is p bar. Okay. Let us take this distance. So take it as d. Okay. It's a distance from x-axis is d. Now see what we can do here. L bar is equal to r bar cross p bar. But remember, we are not knowing the location of the particle. It can be anywhere on this line. And second thing, momentum vector may be along positive x or maybe along negative x. So we are not knowing this. Then what we are doing is we are multiplying magnitude of momentum with perpendicular distance. So mv into, you can see now in this diagram, the value of r sine theta. The value of r sine theta is nothing but d. So imagine a line passing through point parallel to p bar. This is the direction of p bar. Okay, maybe right side p bar or maybe left side. Then separation between these two lines, that is now d. So m into v into d. This is now magnitude into n cap. Okay. So right now we don't require direction part, because since velocity constant, for example, it is moving along positive x-axis. Okay, in this way. Now here direction of r bar cross p bar is into the board, that is minus k cap, which is a constant. So no change in direction. Okay. Next, mass is a constant, v is a constant, d also constant. Okay. Its distance from x-axis is not changing. So no change in magnitude, no change in direction. That means L bar is a constant. Okay. And here one more thing we have observed, that if we are changing the point, L bar changes. Okay. But remember here, wherever we are taking the point, value changes, but that value is always a constant. I am repeating. We can take this point anywhere, its value will be constant. That value may change. For example, if you take a point, or if you take a point on this line, in the sense, this line means that line equation is y equal to d, right? So this line equation, what is this? Y equal to d, line equation. If you take the point anywhere on this line, okay, if you take that point on this line anywhere, then what happens is between r bar and p bar, angle either 0 or 180. That means if you are taking point on this line y equal to d, L bar is 0, and that 0 remains a constant that won't change. If you take any point other than on that line, it will be non-zero. And again, that value remains a constant that does not change. That means here conclusion is that L bar is a constant, no change in magnitude, no change in direction. This value, if you take about any point other than on that line, is non-zero, and that value constant. If you take on this line, it will be 0. Okay. Now see options. Given 0, That is wrong because asking with respect to origin, right? It is moving along a line parallel to x-axis. So it is non-zero. Remains a constant. Yes, it is correct. Okay. So correct option is B. See next one. A particle of mass 1 kg moving with a constant speed of 10 root 2 meter per second along the line y equal to x plus 5. Find its angular momentum about origin. So mass is given 1 kg, speed 10 root 2, along the line y equal to x plus 5. Let's see how to solve it. Condition given that m equal to 1 kg, velocity given 10 root 2 meter per second, meter per second. It is moving along the line y equal to x plus 5. Taking all are in meters. Okay. I think that is not mentioned in the question. Take all are in meters, x and y. Right. Let us draw now. Suppose this is y-axis. This is x and this is y. And you can see here, it is a line equation with a positive slope and positive y-intercept. Okay. Slope is a positive and positive y-intercept. That means we can take the line. Slope is positive, positive y-intercept. That line will be like this, right? This is now y equal to x plus 5. That means this length equal to 5. Okay. So now you can say the particle can be anywhere on this line. So we cannot write r bar. Okay. And direction of p bar. Either it may be like this p bar or it may be like this. So in this, we can calculate what is the magnitude of angular momentum. Okay. See how to calculate. L bar equal to R bar plus P bar. So in this, what we are doing is we are focusing on only modulus value. That is M into V into perpendicular distance R sine theta. Okay. Focusing only modulus value. And to find this R sine theta, what I am saying is you just imagine one line passing through the point, means about which point we are calculating angular momentum. You just imagine one line. Okay. Now separation between these two lines is r sine theta. Okay. And here slope is 1. Slope 1 means this angle is 45. Means this also 45, right? This is 90. This also 45. This also 45. So if I'm taking now this triangle, you can see here, take it as O, A, B. If you take triangle AOB, in that AO becomes now hypotenuse and we want BO, which is R sine theta. That means BO is equal to how much? It is a 5 cos 45, means 5 by root. Substitute that here. Mass 1 kg, velocity 10 root 2, R sine theta 5 into 1 by root. That is now 50. Okay. And units are mass, that is kg. velocity. Velocity is now meter per second, right? And this is again meter, right? So mass kg, meter per second into meter, kg, meter square per second. Okay, cross check once. Mass, that is kg. Velocity, meter per second. Again, length, right? R is length. Again, here meter. So kg, meter square per second. So like this, we can calculate angular momentum. Let us see next problem. Let's see the question given. A particle is projected at time t equal to 0 from a point P on the ground with a speed v0 at an angle of 45 degree to the horizontal. So time t0 from ground with a speed v0, 45 angle. Find magnitude and direction of the angular momentum of the particle about to P at time t equal to v naught by g. So asked for 6 marks 1984. So taking here oblique projectile. Let's see once. Given oblique projectile. Let us take this as x-axis, means horizontal as x-axis, and vertically up as positive axis. So it is now follows parabolic path, and you can see at one instant, its location means particle is now suppose somewhere here. Now we have to focus the definition part. L bar equal to R bar cross P bar. So what is a position vector and what is momentum vector? Okay, we can see now this is a position vector R bar, and momentum vector, it is always along the tangent, that is P bar. Okay, now we can see R bar. R bar means x I cap plus y j cap. Okay, P bar m into u cos theta I cap, because horizontal component of velocity is a constant. Okay, coming to along vertical, it is u sin theta minus gt. It is j cap. Right. Let us make calculation. R bar cross P bar. L bar equal to, so taking here I cap and j cap, coming to I cap, R bar in the place of x. See what we can write? X equal to u cos theta into t. Y equal to u sin theta into t minus half gt square, right? Substitute values here. I cap, j cap, in the place of r, but it is x. X is now u cos theta into t, and coming to j cap, it is u sin theta u sine theta into t minus half g t square. That is r bar. Okay, first one r bar. U cos theta into t. It is u sine theta into t minus half g t square. Coming to p bar, it is m into this is first one u cos theta. It is u cos theta, and this is now m into u sine theta minus gt. U sine theta minus g. Now see calculation. U cos theta into this value. Then see what we get here. U cos theta into this value means, yeah, it is u cos theta into t into u sine theta minus gt, right? So u cos theta into t into m u sine theta minus gt minus remaining is also what is this one? M u cos theta into u sine theta into t minus half g t square. And I am taking for overall one. Direction part is, it is a k cap, right? I cap cross j cap, it is a k cap. So remember, now we have to simplify this. Now see calculation part. I can take m outside. Okay, m outside. Here having u cos theta. So here having u and here also u, right? So take m outside and u also outside. Now see the remaining part calculation. Cos theta into t. This is now sine theta, right? And here cos theta u sine theta into t. Okay. These two get cancelled, right? See carefully. Cos theta t into sine theta. Okay. U sine theta, that one. And here cos theta u sine theta into t. These two gets cancelled. Remaining is now here u cos theta into t minus gt. That means what is out at this is m mu, or let me take separately to avoid confusion. Right. So I'm taking it first of all m u cos theta t and this minus g, m u g t square, m u g t square cos theta, and this is minus. Next, see what is left. Next, this part at remaining part. It is again minus m, sorry, minus of minus plus, right? Plus m u cos theta half g t square. Okay. And for enter one minus enter one, it is k cap. Now see what we get. This is mu cos theta. I will write here half, and this is 1 minus half mu cos theta into g into t square. Cross check once calculation. This is minus, this is a plus. Okay. That's why minus half m u cos theta, and g is there, g t square into k cap. Okay. So we got now for oblique projectile angular momentum as a function of time. Okay. Now in this we can substitute the given time. Then we get the answer. Right. And you can say one more thing. In case of oblique projectile, angular momentum about the point of projection. If you focus modulus value, if you focus modulus value, then that is proportional to half is a constant, mass constant, u cos theta g constants. Only variable is now t. Okay, so it is proportional to t square. Okay, if you are taking the modulus of L bar, it is a proportional to t square. Means if you plot a graph for modulus of angular momentum versus time, it will be parabolic. Okay, so in this problem, what we have to do now? Just substitute the value of t in this one, we get the answer. Okay. So any question they ask on oblique projectile, we can use now this result directly and just putting values in this. Okay. Result is, so direction part is minus k cap. It is minus k cap, means direction is into the plane of the board, right? Because k cap is outwards, normal to the plane of the board outwards. It is now into the board. So minus half m u cos theta into g into t square, right? Okay. And we can see next question also, same again, same question. Asked in 1990 for 2 marks. Mass given, velocity given, angle 45. Magnitude of angular momentum about point of projection when it is at its maximum height. So in that expression, maximum height means what we can do? Time equal to half of time of light. Just putting the value in that, we get the answer. Okay. So I hope you got a clarity.